Let's take a look at the difference between physical and chemical change. This is Dr. B, and we learned in the last slide that a chemical process always involves the formation of a new substance, whereas a physical process does not. You end up with the same things you started with. Perhaps they've dissolved, perhaps they've frozen, but it's still just a physical change. Let's begin by looking at a process that is truly chemical in nature. I'm going to focus on the reaction that occurred in the space shuttle back when it was flying and these two white tanks. They took some aluminum and ammonium perchlorate. So for aluminum, we can simply write Al. No, we don't have to write Al2 since it's not on the H. Broncliffe list of diatomics. And ammonium perchlorate, neither of those are elements, but you can find them on a list of polyatomic ions or just memorize it. Ammonium is NH4. Perchlorate is ClO4. They're both +1 and -1 respectively. So there's our reactants. You might try to guess their physical states, S for solids, AQ for aqueous, that sort of thing. But let's just cover the basics here. Now the products that are formed are nitrogen. Should we write N? No, it's on the H. Broncliffe list. It bonds to itself once it forms, so that's N2. Aluminum oxide, that would be Al2O3. And water is H2O. It also forms the aluminum chloride shown there, and those are the products. Now this is an example of a chemical reaction that's very difficult to balance. When you have a polyatomic ion that decomposes, and both of these do, there's no NH4 on this side, there's no ClO4 on each side, they're particularly difficult to balance it. Give it a shot if you want, or just write down 10 to 6 to 3 to 4 to 2 to 12. Is it balanced? I see 12 oxygens plus 12 oxygens. That's 24 oxygens on this side. This 12, by the way, came 4 times 3. 4 aluminum oxide molecules, each of which contains 3 oxygens. So we should have 24 oxygens on this side as well to be balanced. 6 times 4 is 24. Looks like it checks out. Let's try to guess if something is a chemical or a physical process. Always look for a new substance being formed. If it did, it's chemical. Ice is melting. We're forming some H2O liquid, but we started with H2O just in a different phase, so no, that's physical change. We're mixing vinegar and baking soda. Acetic acid plus sodium hydrogen carbonate. It's going to form some outgassing, which is carbon dioxide. That's a new substance. This is a chemical change. A car rusts. Iron turns into iron oxide, a new substance, chemical. We're mixing sugar and water. The sugar will dissolve in the water, but it's still simply dissolved sugar, therefore physical only. Firecracker explodes. That produces all sorts of new gases and is certainly chemical in nature. We have a container which is pressurized until it bursts. There's nothing, you might ask what's making it pressurized, but if it was simply due to heating it up and nothing changes inside, that would be a physical process. This is an introduction to physical versus chemical change.